Section 6.2, the trigonometric functions of angles. So trigonometry originated historically as the ratio of sides of right triangles. And so if triangles have equal angles, which these two triangles do, then the ratio of those corresponding sides are proportional. So if we were to label this triangle ABC, this triangle would be A prime, B prime, C prime. And if the side lengths are proportional, then the ratio of A to B in that triangle is going to be the same as the ratio of A prime to B prime in that triangle. So I'd like you to pause the video now and see if you can write down, if you remember from geometry, what the sine, cosine, and tangent are in terms of the sides of a right triangle. So we're going to let this side angle be our theta, and remember our angles are the same, so they're both a theta, and this is our right angle. Okay, so pause the video and write down what the sine, cosine, and tangent should be. So hopefully you remembered that the sine of an angle is the opposite over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. So perhaps you remember the mnemonic you were given in geometry to remember sine, cosine, and tangent is so, ka, toa. So sine is opposite over adjacent hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So now that we have those, let's label this triangle that we have in this problem. If an acute angle theta is, or if an angle theta is acute, so let's just call this one theta. We could use that one if we wanted. And the cosine of theta is 2 over 3. So the cosine is the adjacent over the hypotenuse. Well, remember the longest side is the hypotenuse, so the adjacent over the hypotenuse. Find the other trig functions. So I'd like you to pause the video. You're going to have to use the Pythagorean theorem to find your third side, and then use those definitions above to find the other 5 trig functions. So using the Pythagorean theorem, we found that our third side was the square root of 5, and keep those as radicals rather than decimals because we want to deal with exact answers, and decimals just get too sloppy. So then using the definitions that we have above, we have our 5 other trigonometric functions. And hopefully you can notice that the sine and the cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So this brings us to our reciprocal identities. And so these are our reciprocal identities. And so sometimes it's just as easy to, if you're given a fraction for the sine, rather than do 1 over that fraction, just flip your fraction, right? They're reciprocals. Sometimes we need to actually do 1 over that reciprocal identity. So now there's some special angles in trig and geometry, and we're going to learn those trig functions for those 3 special angles, basically 30 degrees, 45 degrees, and 60 degrees. And you're going to, at some point, you will inevitably and need to remember what those trig functions are. But they're derived fairly easily. And so we're going to go through how we come up with those. So to begin with, we have an equilateral triangle with side length 2. So this side is 2, and this side is 2, and this side is 2. The reason I didn't write that 2 is we're going to draw this altitude in, which is going to form a right angle there, which means this side is 1 and this side is 1. Now again, remember we started with a complete equilateral triangle, which means this angle is 60 degrees and this angle is 60 degrees. This angle, because it was an altitude of an equilateral triangle, has broken this into a 30-degree angle and a 30-degree angle. And so this is where we come up with our 30, 60, 90-degree triangle. So now to help it so you don't have an excruciatingly long video to watch, what I'd like you to do is use the Pythagorean theorem to find that third side, that third leg of the triangle. And then using those definitions that we had on the first page of our notes, I'd like you to go through and write down what the sine, all 6 trig functions of a 30-degree angle are. So using that angle as your theta. And then go through and write down all the 6 trig functions for the 60-degree angle. So using that angle as your theta. So go ahead and pause the video now and try to do those on your own. So there we have those 6 trig functions for 30-degree angles and 6 trig functions for the 60-degree angles. Be aware of some of the cool patterns that you might see. Trig is full of all these cool patterns. So, and some of these are actually going to be coming up in some of the identities and formulas that we're going to be using later. So try to be aware of those as we're going along. That's unfortunately one of those things that we can't really talk about that we would be able to talk about in class. Okay, now let's consider an isosceles triangle with side length 1. So this is an isosceles right triangle, which means this is the right angle, and that means that these angles both have to be 45-degree angles. So here's our other special triangle. And if we have a side length 1, you're going to have to use the Pythagorean theorem to find the third side. And again, pause the video to find that third side, and then write down what the 6 trig functions are for a 45-degree angle. And there we have the 6 trig functions for 45-degree angles. Now, a lot of what we're going to be doing in trig is in terms of radians instead of degrees. So I'd like you to start thinking in terms of radians instead of degrees. So we'll compare them both right now. So we start with 0 degrees, and all the way around is 360 degrees. So again, remembering the animation that we saw yesterday, if I go halfway around, this is pi radians, which is 180 degrees. If I go 1/4 of the way around, or halfway around, I'm going to have pi over 2, or 90 degrees. And if I go 3/4 of the way around, so 1/2 pi, pi, 1.5 pi, so this is 3 pi over 2, or 270 degrees. So those are the ones we talked about yesterday. And so now we're going to talk about just breaking up the radians. So if again we start at 0 and we have pi over 2, and over here we have a full pi. So think of this simply as 1/2 pi. This is 1 whole pi. So if I divide this first quadrant in half, well, that's going to be 1/4 pi, right? Or pi over 4. So 1/4 pi, 2/4 pi. Breaking this one in half, we're going to have 3/4 pi, or 3 pi over 4, and pi, 1 pi. Now let's break it into sixths. So we have 1/6 pi, pi over 6. 2/6, well, 2/6 is 1/3, so this is actually pi over 3. 3/6 is 1/2. 4/6, oh, but 4/6 is 2/3, so 2 pi over 3. 5/6, 5 pi over 6, and 6/6. So start thinking about the unit circle and those special angles as this is a 30-degree angle, this is your 45-degree angle, this is your 60-degree angle. So start trying to think about them in terms of fractions of pi, fractions of 1, and those radians are not nearly as scary. Also, you need to be more conscious now that we're starting to work in radians what mode your calculator is in. It might be in degrees and it might be in radians. We're going to try to be working in radians. Again, I just want you to pause the video. I'm going to write down what these identities are. I guess you don't have to pause the video. I'm going to pause my recording and write down what these identities are, and then I will talk about them. Okay, so the reciprocal identities we talked about just a few minutes ago. One thing I also need to point out regarding those is make sure that you don't think that that sign to the -1 button means 1 over the sign. It does not. It means the inverse sign. We will get to those, but don't use that button on your calculator for 1 over sine. The tangent to theta is sine over cosine, and then obviously because the cotangent is the reciprocal of that, cotangent is cosine over sine. Now the Pythagorean identity is really the only one that you need to commit to your memory is this basic one, sine squared plus cosine squared equals 1. Think about the unit circle. The radius of the unit circle is 1, so sine squared plus cosine squared equals 1. Now, to get the other two, let's think about dividing everything in this by sine squared. Sine squared divided by sine squared is 1. Cosine over sine is going to be the cotangent squared of theta. And then 1 divided by the sine is going to be our cosecant squared. Similarly, if we divide that top pink equation by cosine, sine over cosine is the tangent squared. Cosine over cosine is 1. And 1 over cosine is going to be the secant squared. So you really only need to remember that first one. The other two are very easily derived. I would like to challenge you now to pause the video and try to do this problem, at least build the picture on your own. All right, so here we go. Here's our surveyor standing 50 feet from the base of the building, and he measures the top of the building to be a 60-degree angle. So we need to find out how tall the building is. Well, that's the opposite side from the 60-degree angle, and the 50 is the adjacent side. So I would like you to try to pause the video and set up a trig equation, what trig function uses the opposite and adjacent, and solve that trig function. So we know that the tangent is opposite over adjacent, so the tangent of 60 degrees is x over 50. We know from earlier in our notes that the tangent of 60 is square root of 3. So then I'm just solving a proportion. I'm going to cross multiply. I'm going to find that x equals 50 square roots of 3. Since this is a word problem, I want a meaningful answer. I don't know how tall that is exactly, but I do know how tall 86.6 feet are. Now, verifying identities is probably going to be the hardest thing to teach remotely. It's a lot of trial and error, and it's a lot of frustration, and there's more ways than one to solve these. So I'm going to do each step by step and see how you follow along. First of all, when you're verifying identities, you can only work on one side. So we can't bring that cosine over to if we need something later on. You can only work on one side. You're trying to get one side to equal the other side. So you typically are going to start on the more complicated side and try to simplify it. And oftentimes it's easiest if you put everything in terms of sine and cosine. So that's what I did in the first step. And now I see that in my first parentheses I have a common denominator. So I am going to take care of that and write it as one fraction. Now, the better your algebra is, sometimes the easier these problems are going to be, because much of what we're going to be doing in trig is algebraic in nature. So if I were to multiply these two fractions together, I notice that my numerators are a difference of perfect squares. So now I'm going to just multiply these two fractions together, which I multiply across the top and across the bottom. So foiling those together, or recognizing that it's a difference of perfect squares, that's what I get. And then I noticed that I had a sine squared, so I looked up at my Pythagorean identities, and that first one, if I kind of rewrote that, subtracted sine from both sides, I'm going to get 1 minus sine squared. So now if I use that substitution, I can finish the problem. So I end up with cosine squared over cosine, so the cosine is going to cancel with one of those. I end up with cosine theta, which is what I had started with. If you want to try, go ahead and do the second problem. Otherwise, I am going to do this, and I will reveal my answers. So first of all, I broke that one fraction up into two separate fractions. So I took the denominator and wrote it under each part of my numerator. Now all I did is I wrote tangent in terms of sine over cosine. Then to get rid of my complex fraction, because you can't have a fraction within a fraction, I multiplied top and bottom. I basically multiplied that first fraction by 1 over sine over 1 over sine. That allowed those sines to cancel, so I was left with 1 over cosine, because my denominator equals 1. These cancel, so I end up with 1 over cosine. And I also noticed that cosine over sine from up above is cotangent. And now finally, 1 over cosine is secant plus the cotangent of theta equals, and that's what we started with. Okay, so placing angles on the rectangular coordinate system, I've got my rectangular coordinate system. I'm going to move out x units, and I'm going to put that x there, and I'm going to move up whatever my y units are, and this is going to be my angle. This is going to be my theta, and I can find my r. So using just x, y, and r, again, go ahead and write down what the 6 trig functions are in terms of x, y, and r. So using those definitions we had earlier, we have those in very general terms. And now using that x and y is now negative 15h. So go ahead and do example 4, please. And there's that r and those 6 trig functions. Keep in mind your r doing the Pythagorean theorem is always going to be the positive number. Now I would like you to try to do example 5. So I graphed the line y equals 3x. It goes to the origin, and I picked the most convenient point, which would be the first point down in the third quadrant. And then I found, using the Pythagorean theorem, what my radius would be. Keep in mind your theta is always at the origin. And then those are your 6 trig functions. We will see you in class. Come with questions.